Alright, so talking about address resolution protocol, we talked about it a little bit in an overview sense in the last week. But the idea behind your address resolution protocol, for those of you that haven't worked with it in a while, is to compare the MAC addresses, your physical MAC addresses with the NIC cards, to the IP address, and being able to see those ARP frames and examine Ethernet headers, and then be able to explain their impact and host performance, and as well as some potential security risks. So the correlation between your MAC address and your physical IP address is one that you guys will have to get familiar with, especially when you're trying to do some troubleshooting. The physical MAC address is used in the Ethernet NIC and the Ethernet frame that comes across there. If the destination IP is on the same network, then the destination MAC address of that will be of the destination device. So for example, if we're starting with A and we're going to the file server, it could communicate directly with the file server. However, if it's down below or has to route through something, then the final destination is going to be something like this one here. So it may have to jump and then jump from here to here. On the logical address, this is what's used to send the packet from the original source to the final destination. So that destination IP address may be on the same network as the source, or it may be on this remote network. But this destination MAC is always going to be like your default gateway if it's not on the same network. When working with a remote network, the destination MAC address of the host will always be the host default gateway. Just kind of explain there. So routers will examine the IPv4 address, and then the router will receive that Ethernet frame, de-encapsulates the layer 2 information, so it goes to find the MAC address, where are you trying to go to. Using the destination IP address, the router will then do a lookup for the next hop device from it in its routing table, and then encapsulate that packet with a new data link frame for the outgoing interface, so it'll head out this direction. So if it comes in here, it goes to here, goes out, it recapsulates it here to here, checks it again, re-encapsulates it so that it can get over to the file server. If that next hop device is the final destination MAC, then it's aware of the device's NIC address. So ARP in and of itself, the problem here in this kind of figure says I need to get information to 1.7, but I only have the IP address and don't know the MAC address of the device that has the IP. So what ARP will do is it'll send out a ARP request that goes out here. It goes out to the switch, and that switch will end up doing ARP requests out to try to see if it knows what it is. If it already knows what it is in its MAC lookup table, then it will go ahead and send that information back to the original host. And that's kind of the benefit of a switch versus the old days we had hubs. So when a packet is sent to the data link layer to be encapsulated into a frame, the device refers to the table called the Arp Table, and you can look this up on your PC, or the ARP cache, and it's generally in your RAM in order to find the MAC address mapped to the IPv4 address. It will search through its ARP table for a destination IPv4 and then corresponding MAC address if the packet's destination address is on the same network. If it locates the address, then the corresponding will be used to the destination MAC address frame. So as he sends out this request, this switch or this device responds that, hey, that's me, here's back my MAC address. It will go back through this way. These guys say it's not me, and therefore they don't actually send anything back. You guys will see this video inside of your lab, or your sections and modules on NetLab, on NetAcad. Alright, so I'm just going to skip those. You guys will be able to understand that. So when you remove entries from here, this will remove an ARP entry if it's not used for more than 15 to 45 seconds. That's just what it has for a default timer, cache timer. And the idea is that it doesn't end up getting poisoned, so it has to go out and find that. The longer the ARP request there, you may manually enter those in to your MAC table. Particularly on routers and switches, you may need to do that if you want to make sure that they're static all the time for a given IP address. What they're leading into is what's called ARP poisoning and ARP caching. And we can poison and tell it, instead of this thing and this guy responding that, hey, that's my MAC address, I can come up here with this guy and say, hey, nope, that 1.50 is actually my IP, send it to my MAC. and then from there he's actually going to steal the traffic that was destined to go over here. Then he can repeat this traffic out the other link and go back this direction. So this guy is never the wiser, doesn't know that things are being stolen in between. So Arp Tables, like you said, here on a routing or a Cisco device, you can do show IP ARP, and you can get those IP addresses translated over to hardware MACs. Note that on a Cisco device, you're going to see the 4 characters and then period notation. When you're going to look at it on, like, say, a Windows machine or a Windows 10 machine here, you'll use ARP-A, and you'll see it with the dash notation in between. So you guys will have a lab where you guys go through and examine those. Most of the labs this week are going to be utilizing Wireshark and diving into the frames, so seeing if you can identify ARPs and being able to identify different types of packets that you can see going through the network. So as we mentioned in that little bit there of ARP spoofing, so ARP broadcasts everything out as an ARP request. It's received and processed by every single one of these devices. So in a typical business network, these broadcasts will have minimal impact on network performance. There's not a lot of data being generated there. However, if many of those devices start accessing the network service at the same time, there can be a reduction in performance for a little bit. After those devices send out the initial ARP broadcast and have learned the necessary MAC addresses, the impact is pretty minimal. So as you put a device on a network, it floods the network and tries to get all the ARP information and then brings it back. Once it's built a table, it's usually not a big deal. You're not going to be sending out requests all the time. However, with ARP spoofing, as I was mentioned before, it leads to a potential security risk. So what happens is this threat actor over here is to perform an ARP poisoning attack. It's used to reply to an ARP request for an IP address belonging to another device, such as the default gateway, which is typically what we would attack. In that case, we would send an ARP reply with its own MAC address, and therefore the receiver of that ARP reply would add the wrong MAC address to its ARP table and then send those packets over here to the threat actor. Again, the threat actor can re-encapsulate those packets and send them on out to the gateway if it chose to do so. So you'll see this video on ARP spoofing there. So ARP, just as a quick recap, it's address resolution protocol. It's to convert an IPv4 address to a layer 2 address so that you can start sending data over the wire back to the original MAC address or to the destination MAC address. If there is a hop in between, in other words, it's not on the same network, then it will have to re-encode that MAC address every single time in order to get to its final destination. It will always keep the destination IPv4 address built up in the table or in the packet. There's no entry for IPv4 address in the MAC table. It sends out that big broadcast. Note that ARP poisoning or ARP spoofing is what is referred to as the threat with this particular protocol. And particularly, we usually attack the default gateway. We want to pretend like we're the router because everybody sends their default traffic out that direction. And that covers ARP protocol. Stop this one.